Alright, so we're going to do some concentration problems using our titration equations. And we're basically going to do the same process through most of the titration problems. I'm going to pull out the information as I read it, and I'm going to put it on my picture so that I can keep straight of what's going on in my head. So we've got an unknown concentration. Our unknown concentration goes down here. It says it's HCl, and we have 50 milliliters of it. Now our thing that we have known concentration is going to go in there, and it says we've got 10 milliliters of a 0.1 molar solution, and it says it's sodium hydroxide. With this molarity, that's a conversion factor, so right away I'm going to change it into moles per liter. Okay, that's something we can use. Now we do need one other thing. We need a balanced chemical equation. So we've got HCl reacting with sodium hydroxide, and it's going to, remember, strong acid, strong base, we're only going to write the forward reaction. It's going to water plus a salt. Sodium chloride is our salt. And I know that's soluble, so I'm going to write an AQ there. So this is a balanced chemical equation the way it is. Do keep in mind this has to be balanced in order for us to do our calculations. So there's three questions I said we're going to use when we're doing titration problems, and they're always the same three, pretty much. So the first question is, how many moles of our known volume, known concentration solution do we have? So that's the thing up here. So we're going to first figure out how many moles. This is a problem just like the other ones that we've done. We start off with a thing that's not the conversion factor, and this is of our sodium hydroxide. And we're going to use our conversion factor, our concentration, to change it to moles. Volume is in the top, so we need volume in the bottom in order to cancel out. But we know that liters and milliliters don't cancel out, so we need a conversion factor. Liters is in the bottom, so it has to be in the top. Milliliters is in the top, so it has to go in the bottom. 1 liter for 1,000 milliliters. Right? Cancel out our units. The only units we haven't canceled out are moles. And then we can go ahead and do this calculation. 10 times 0.1 divided by 1,000, and we get 0.0010 moles of our sodium hydroxide. Now we're going to use our balanced chemical equation and our molar ratios to convert it from moles of our unknown to moles of, or from moles of our known to moles of our unknown. So we've got 0.0010 moles of sodium hydroxide. We want to get rid of our moles of sodium hydroxide, and we want to go to moles of HCl. We're going to use our balanced chemical equation. Remember, 1 is the coefficient here, 1 is the coefficient here. Even though it's 1 to 1, I want to see this part of the problem because it does change units. Moles of sodium hydroxide cancels out with moles of sodium hydroxide. So the thing we have left ends up being moles of our HCl. Now we're in a different, talking about something new here. And it is a 1-to-1 ratio, so the number ends up being the same thing. Now our final question, we're not done yet. Our final question will be to answer any question that they give us. Because at this point, they could ask us a number of different questions, have us do different calculations, and we can answer it. So it simply asks a very straightforward question, what's the concentration? Well, we know that we have 0.0010 moles of our HCl. We know it's in 50 milliliters, so it's in 50 milliliters. We need it in moles per liter for concentration. Not a problem, we just have to change the milliliters to liters. Milliliters is on the bottom, so we need it in the top. Liters is what we want in the bottom. 1 of those guys to 1,000 of those guys. And our units end up being moles per liter of our HCl. And we can go ahead and do this calculation. We ended up with 0.020 moles per liter of HCl. Remember, moles per liter is simply molarity. So there's our concentration. So let's work another one, and like I said, we're going to ask the exact same three questions. This time I'll draw my little picture and read the problem and write our stuff out. So this time we've got an unknown concentration, and our unknown is sodium hydroxide this time. This time the base is down here, and we have 33.48 milliliters of it. Now it titrates and it changes color or reaches the end point, it means the same thing, at 25.0 milliliters, and the concentration is 0.108 molar, and it's H2SO4. Now, of course, the concentrations, I'm going to write it out into something I can use, moles per liter. The other thing we need before we get started is a balanced chemical equation. This time we've got sodium hydroxide reacting with H2SO4, and it gives us our water plus the salt, sodium sulfate. Now remember, sulfate's -2 charge, so we need 2 of the sodiums there. When we go to balance this guy out, we need a 2 here, that's 2 sodiums. We've got 2 hydroxides and 2 H's to make 2 waters, and 1 and 1 for the sulfate. So watch, make sure you get a balanced chemical equation there. The questions are still the same. How many moles of our known thing? Our known thing is 25.0 milliliters of our H2SO4. We are going to use concentration to convert that. Our volume goes in the bottom because we've got volume on the top. 108 moles. Now milliliters and liters can't cancel out, so we need a conversion factor. Liters in the top to cancel out there, milliliters in the bottom to cancel out there. One of those guys to 1,000. Cancel out those units. And we end up with moles of our H2SO4. Exact same problem we did last time, only this time we've got different numbers in it. So we end up with 0.0027 moles of our H2SO4. Now keep in mind, this is the number that we bring down to do the next problem. We've got 0.0027 moles of the H2SO4. We want to cancel out moles of H2SO4, so that's what goes in the bottom. We look at our coefficient here, and it's 1 mole. We want to go to moles of our unknown concentration, which is our sodium hydroxide. Coefficient there is a 2, so we put a 2 there. We do this problem, and we get 0.0054 moles of our sodium hydroxide. And our final answer, we want to actually answer the question that they give us. Again, it's a straight concentration question, so we're going to take our 0.0054 moles of our sodium hydroxide, divided by the volume. The volume was 33.48 milliliters. We need moles per liter, so we have our 1,000 milliliters over 1 liter, and that's going to give us moles per liter for the sodium hydroxide. So we're going to multiply it by the 1,000 divided by the 33.48, and we get 0.161 moles per liter, which is 0.161 molar of our sodium hydroxide. There's our concentration. Okay. Now, just to re-emphasize that we are doing the exact same questions every single time, we're going to do one more titration problem, and this time I'm only going to change the things on the previous problem that will be different. Okay? Everything else I'm leaving the same. So let me do this little editing here. All right, so this time we're doing a problem where we've got 20 milliliters of our HCl. This time we're titrating it with KOH, and we're going to have 22.7 milliliters, and the concentration is 0.153 molar, which 0.153 moles per liter. Okay, so the problem is basically set up exactly as we did before. Here we're going to have potassium hydroxide. Let's fix our balanced equation. This time it's potassium hydroxide goes to potassium chloride. Okay. So we're just going to bring down our milliliters, 22.7 milliliters of potassium. It's 0.153 moles per liter. The conversion factor stays the same, so 22.7 times 0.153 divided by 1,000, and we get 0.00347. That's the number that comes down here, 0.00347 moles of KOH this time. Our ratio is still 1 to 1, so we end up with 0.00347 moles of our HCl. Now we answer our final question, 0.00347 moles of our HCl. It is in 20 milliliters. And so when we take that, we get an answer of 0.174 moles per liter, which is 0.174 molar of our HCl. So hopefully from that problem, so you can see that final part of it. From this problem, I'd use the exact same framework of the HCl and sodium hydroxide problem I did at the beginning. The only thing I changed was the sodium to potassium and the numbers that were specific to this particular problem. You can see that the steps are all the same. You find how many moles you've got of the thing that you have both concentration and volume for. Then you convert it from moles of the thing you know to moles of the thing you don't know. Then you answer the final questions. Oftentimes the final question will be asking you for the concentration of the thing that you didn't know the concentration for. So then you just put your moles over your volume and make sure it comes out to moles per liter so that you can get your correct concentration units. 3 steps to every titration problem. So do practice using that as a framework to work out these titration problems.